The hardest thing about converting between metric and US units is that the conversions, the unity fractions we have to use to convert between them are typically, weird fractions or weird numbers. Like all of these things you see, we have numbers that are very, very, long decimals, and it makes the decimal numbers longer. But the way we convert them is still the same. We use unity fractions and we multiply, canceling units where we can to try and get our desired unit at the very end. Let's do some of these and then move on to some application type problems. First off, 20 foot 6 inches into meters. We need to change this to either completely inches or completely feet, and then convert it to meters. Between the two conversions, have inch to centimeter, foot to centimeter, yard to meter, and mile to kilometer. It seems probably the best way is going to be going from inch to centimeter. Probably be the fastest way. So first off, 20 feet equals 12 inches and 1 foot. And this gives us 20 times 12 is 24, 240. 240 inches, and then we're going to add on to that 6 inches, so we have 246 inches. Then we can convert this into, let's say, I want to make sure my mathematics is correct, 240 inches. We have 240 inches plus 6 inches equals 240 inches over 1 times 1 inch is 2.54 centimeters. So 1 inch is 2.54 centimeters. And there is 100 centimeter in 1 meter. Okay. And it looks like we have our desired unit. So now we just need to multiply it all out. 246 times 2.54 on top divided by 100 on bottom gives us I'm going to round to 2 decimal places, 6.248, so 6.25 meters. All right, 3 pound 4 ounces into kilograms. Let's see, pound to kilograms right there. So maybe that's the best thing to go for. 3.4 ounces. 4 ounces is, there's 16 ounces in 1 pound. You see we have 4 over 16, which is 0.25 pounds. So then 3 pounds plus 0.25 pounds, which is 3 pounds 4 ounces, equals 3.25 pounds. And the conversion was 1 pound equals 0.4536 kilograms. 1 pound equals 0.4536 kilograms. Our units cancel. And we get 3.5 times 0.4536. Rounding to 2 decimal places gives us 1.47 kilograms. Okay, 61 miles per 1 hour. To convert this into kilometers per hour, all we have to do is convert between miles and kilometers. And that one is right here. 1 mile is 1.6093. 1 mile, 1.6093 kilometers. Miles cancel, and we have kilometers on top over hour, kilometers per hour. That's what we want. So we can just multiply this out. 61.0 times 1.6093. That gives us 98.1673 kilometers per hour. Now for these units, I didn't do the previous ones because those were 20 feet, 20 foot 6, and then 3 pound 4 ounces. But this one here has 61.0 miles per hour. We can actually use significant figures to find out how many places and where to round to in the very end. In 61.0, there are 3 significant figures. That's because 61, those are both non-zero digits. And this 0.0, if you have something written as 0.0 or 0.00, that means you have something measured to that accuracy. In this case, it was measured to the 10th place accuracy. So there's 3, 6, 1, and 0, 3 significant digits here. So we need 3 significant digits in 98.1673. Well, we start with from left to right. There's 1, 2, 3 significant figures. So we're going to go to that place. Look at the next one. Is that 5 or greater? It is. So we add 1 and drop the rest. This gives us 98.2 kilometers per hour. 1, 2, 3 sig figs. 1, 2, 3 significant figures. Same accuracy in the beginning that was given to us as that we ended with. So for this next one, it's telling us to round to the 10th place. We'll see if that lines up with significant figures at the end of it. So let's just do this. 512 cubic inches. You want cubic inches to cubic centimeters. Look back up here. And cubic inches to cubic centimeters. 1 equals 16.387. 16.387. Let's see, 1 inch cubed, 16.387 centimeters cubed. You see our units cancel. We get 512 times 16.387, which gives us 8390.144. And rounding this to the nearest 10th, this is the 10th spot, so we get 8390.1 centimeters cubed. How many significant figures do we have in the beginning problem? Well, looking here, we have 3, 5, 1, and 2. So if we wanted to do that, if we wanted to round to the significant figure accuracy, we start with the leftmost space. We have 1, 2, 3 sig figs there. So we're going to round to this place. Look at the next one, it's 0. We do not add 1, so we can just ignore that. And we can drop the decimal part. Everything past the 9 in this case, everything past the point where we round to is going to be changed to zeros if it's further to the left of the decimal point. If it's further to the right, then we just drop the decimal. So we have 8390 centimeters cubed. This has 1, 2, 3 sig figs. This has 1, 2, 3 sig figs. So it matches our answer's significant digits. However, the problem itself asks to be rounded to the nearest 10th. So that's what the top one is here. Whatever the problem asks for, round to the nearest 10th or round to significant digits. That's what you have to do. All right, for this one, let's round to significant digits. We have 1, 2 sig figs. The 0 has no decimal point written there. If it did, that's when the 0 counts. Up here, we have a decimal point written here, and the 0 now counts. Because the decimal is not written, we assume that every 0 number that's around where the decimal point would be, it didn't count. Okay, 2 and 6 are both significant figures. So let's round to 2 sig figs at the very end. First, we need to actually do the conversion. Well, let's do milliliters to fluid ounces. Let's check that out. Let's see. Ounces, milliliters. 1 fluid ounce equals 29.574 milliliters. 29.574. Let me make sure of that. Yep. And that's 1 ounce. Fluid ounce, of course. Right, yep. As opposed to like a weight, a mass ounce. Okay, all we have to do is then divide 260 over 29.574. That gives us 8.791506 fluid ounces. We have 2 significant digits there, so we want 2, 1, 2 there. Look at the next one. Is it 5 or greater? It is, so we're going to add 1. That gives us 8.8 fluid ounces. This means that both 260 milliliters, the number we started with, and 8.8 fluid ounces, the answer we got in the end, have the same error accuracy. 260 has 2 places of accuracy, 8.8 has 2 places of accuracy. That's what significant digits, significant figures is all about. Okay, for this one, we're rounding to the nearest tenth. 4.50 metric tons. I believe that's TONNES. Oh, it's lowercase t. Okay, we need to change this to pounds. Let's see. We can go from a metric ton to a regular ton, and then we can use 1 ton to 200 pounds. We could also convert metric tons to kilograms and then kilograms to pounds, but I think this way will work. So 0.9072 metric tons to 1 ton. 9072 metric tons to 1 ton. And then 1 ton has 2,000 pounds in it. You see our tons cancel, our metric tons, and this is the regular tons. And we have pounds left over. So doing the actual multiplication, gives us 9920.634921 pounds. Round to the nearest tenth. Let's round to this spot here. So that would be 9920.6. And we can calculate if we wanted to rounding to significant digits. So we have 1, 2, 3 sig figs in the starting point, in the starting position. 1, 2, 3 significant figures would be at the 2 there. But if we wanted to round it to significant digits, then we would round it to 9920 pounds. Because now we have 1, 2, 3 significant figures, just like we did in the beginning here. So that's how the rounding works differently. If it's given to you some way specifically, round to that way. In this case, it's a tenth. So that wouldn't be the answer, right? We would have this being our answer. If it says significant figures, then you need to calculate how many you need and then actually do the rounding. Okay, 1 metric unit of pressure is the Pascal, or 1 pound per square inch PSI is 6894 pascals. 1 pound per square foot PSF is 47.88. Large pressures, we use kilopascals instead. Kilopascal, kilo being 1,000 times as big as the regular unit. So 1 kilopascal equals 1,000 pascals. And so 1 PSI is approximately 6.894 kilopascals, and 1 PSF equals approximately 0.047788 kilopascals. Okay, let's convert between 15 PSI to pascals. Nothing's written here, so we're going to tend to do significant digits. There are 1, 2, 3 sig figs there, so we're going to do 3 significant figures at the end. These 0 counts because we have a decimal point written there. Okay, we have 15.0 psi times, let's see, 1 psi is approximately 6894 pascals. 6894 pascals, and that's what we want. And of course the psi cancel, giving us 10.3410 pascals. And we're rounding to 3 significant figures. So starting from left to right, we have 1, 2, 3. 0 only counts as a significant figure if it's in between non-zero significant figures. So the 1 and the 3 make 0 a significant figure. I'm going to round to this place. Look at the next one. 5 or greater does not. So we would say 103,000 pascals. The remaining zeros in this number, all 3 of those zeros have to be in the answer because that's what tells us it's 103,000 versus just 103. But they do not count as significant figures. Only the 103 do. Okay, 100 psi times how many kilopascals? So we don't have a direct conversion, but we do have from psi to pascals, which we just used. 1 psi equals 6894 pascals. And then we have 1000 pascals equals 1 kilopascal. These two cancel with those two. We're dividing by 10, so we get 6894 pascals. And if we were to convert this to significant figures, what you would see here is the original one only had a single sig fig, which means 6 is the place where we round to. Look at the next one, that's 8, so we're going to add 1. That gives us 700 pascals. The error measurement's very low. All I would have to do is add in a decimal point here, and that would mean that would be 3 significant figures, but since there's not, we won't worry about it. Okay, 40 PSF. We have let me show you where I'm talking. 1 pound per square foot, which is PSF, equals 47.88 pascals. Okay, and that gives us our the unit we want. 40 times 47.88. I think I did that right. Yeah. Equals 1915.2. And we would technically need to round to only 1 significant digit, so we would round it here. So that would be 2000. I forgot to write pascals. Okay, 2500 PSF. Is how many kilopascals. We're going to use the same unity ratio that we used in the previous problem. And now we're going to multiply it by 1000 pascals equals 1 kilopascal. Now we can actually do the multiplication. You can see here that these 2 zeros cancel with those 2 zeros. We get 25 times 47.8 divided by 10, giving us 119.7 kilopascals. Just making sure you see it. The is red. Those cancel, and those cancel, giving us just kilopascals. And this has 2 significant digits. So we're going to go 1, 2, round to this place. That gives us 120 kilopascals as our answer there. All right, let's do some application type problems. Here we have like which car, like a European 12 kilometer per liter of gas, or one that's 25 miles per gallon. Since this is, we're in America, let's change this to miles per gallon, because then we can actually, we know more what that means to us. So I'm going to change 12 kilometers per 1 liter into miles per gallon. So the first step, I've got my conversion chart off to the side here. Let's change kilometers to miles. 1.6093 kilometer equals 1 mile. And then I need to change liters to gallons. And that is 3.785 liters to 1 gallon. And this gives me miles on top, gallons on bottom, miles per gallon. Now all we have to do is do the multiplication and division. 3 giving us 28.22 35 miles per gallon. We should really only have 2 digits. So rounding to 2 decimal places, or 2 significant digits, is 28 miles per gallon. Right? We round to this place is 1, 2. Look at the 2, it doesn't go up. So 28 miles per gallon, 12 kilometers per liter is more than 25 miles per gallon. All right, here we have some fried crickets serving as an appetizer for 5,400 Cambodian reals per kilogram. If we have 4,060 reals, or $1, how much will 5 pounds of crickets cost in US dollars? So what we're doing is we're converting 5 pounds of crickets into US dollars using the ideas that we have, the unity fractions and everything that's given to us there. So kind of where do we start? Well, we need to multiply 5 pounds by something. And we have a couple things: 5,400 Cambodian reals per kilogram, and 4,060 reals equals $1. So what we need is we need to have kilograms. So we can change pounds to kilogram. Let's see. 1 pound equals 0.4536 kilograms. And now we have 5,400 reals per 1 kilogram. You can see how my units are canceling. Now I have reals. Now all I have to do is convert reals to dollars. And we know that we have 4,060 reals to $1. And that gives me a conversion between 5 pounds to some amount of dollars, which we will find here by doing the multiplication. 5 times 0.4536 times 5,400 divided by 4060. That gives us 3.01655 dollars. Make sure my math is correct. Looks good. Okay, and of course this is in dollars, so we don't do significant digits here because dollars has a certain specified quantity. You always round to the nearest cent, which is 2 decimal points past. That's how we use dollars, right? So this is going to be $3.02. That's how much 5 pounds of crickets would cost. All right, an American family is looking for an apartment rental in Europe. They want 1,500 square feet, and there's an apartment that's advertised with 130 square meters. Is 130 square meters big enough for the family? So what we want to do is we want to convert 130 square meters into square feet. The conversion we have here is 0.0929 meters squared equals 1 foot squared. So all we have to do really is divide out that number. Oops. Messing up how I'm writing this. 929. It's 1399.354 feet squared. I don't have to round this because I can directly see that this is definitely smaller than that. So no, it does not meet the family's requirement. A caterer who wants to make eggplants recommends using 1.5 kilograms of eggplants per 8 guests. So let's highlight that. However, in her area, eggplant is only sold by the pound. So we have eggplant sold by the pound, and we know we have 150 guests. How many pounds should be purchased? So we have 150 guests. We want to change, let me be able to spell guests right. We're changing the number of guests into number of pounds of eggplant. That's what we're trying to do here. So first off, let's change guests to some kind of, using this yellow thing here, guests into pounds of, kilograms of eggplant. So we have 8 guests per 1.5 kilograms of eggplant. Now we have guests cancel, and now we have a mass of eggplants. All we have to do now is convert kilograms to pounds. Let's see. 0.4536 kilograms is 1 pound. And you see we have pounds at the end of our unit here. So if you multiply this out, 150 times 1.5 divided by 8 and 0.4536. I'm getting 62.00, which, okay, it goes further, but we only need to round to 2 places. 1.5 and 150 are both 2 places of accuracy, so we only need 2 significant digits, which we have at 62. 62 pounds of eggplant is required. All right, 2016, Usain Bolt ran 100 meters in 9.81 seconds and 200 in 19.78. What's the average speed in miles per hour for both of the runs? And we're rounding to 2 decimal digits, 2 decimal places. Okay, so for part A, we have a 100 meter run. This is 100 meters in 9.81 seconds. That's what he ran. We're going to change this to miles per hour. So first off, let's change meters to miles. Is there a direct conversion on here? No, but there's miles to kilometers. So we're going to change meters to kilometers first. 1,000 meters is 1 kilometer. And now we can convert between kilometers and miles. 1.6093 kilometers to 1 mile. Now we have miles as our distance measurement here. Let's change seconds to hours. Okay, 60 seconds in 1 minute. Actually, I'm going to do a direct conversion. There's 3,600 seconds to 1 hour. You can do, convert seconds to minutes and then minutes into hours, and you'll see it's the same thing as what I'm doing here. I'm just doing this to save a little bit of space on the screen. Okay, now let's actually multiply this out. 100 times 3600 on top, divided by 9.81, 1000, and 1.6093. That gives us 22.8032 miles per hour. Round to 2 decimal places, 22.80 miles per hour. Okay, part B. 200 meter run in 19.78 seconds. We're actually going to use the exact same numbers because we're still converting meters per second into miles per hour. It's going to be the exact same unity fractions that are multiplying. And you can check, meters cancel, kilometers cancel, seconds cancel. We have miles per hour, so that's good to go. Doing this, nine, 7, 8 gives us 22.6187 miles per hour. 2 places, 1, 2, so 22.62 miles per hour. That's how fast he ran, both of them in miles per hour. All right, here we have the cruising speed of a Boeing 737 airplane is approximately Mach 0.74. If the speed of sound at cruising altitude is approximately 295 meters per second, what is it in miles per hour? So we need to take 0.74 times whatever it is in miles per hour. If the speed of sound at cruising altitude is, 0.74 times 295 meters per second it gives us 218.3 meters per second. That's the speed of the Boeing 737 in meters per second at the cruising speed. Okay, now we need to take this number here and convert it into miles per hour. So let's convert meters into miles. We're going to convert meters into kilometers. This is the same as the last problem, really. Meters, and then convert 1 mile, 1.6093. Make sure of that. Yep, kilometers. Now we have miles, and we're going to convert seconds to hours. So we have 1 hour on bottom equals 3,600 seconds. Seconds cancel, meters cancel, kilometers cancel. We have miles per hour. So doing the mathematics gives us, let's see, 1,000 and 1.6093, 488.3365 miles per hour. The starting point here was 3 significant digits, 2, 9, and 5 are 3 sig figs. So we need 3 in their answer, 4, 8, 8. Round to the 1 spot then, giving us 488 miles per hour. Fast plane.